It was a cool, cloudy, and windy June day in Centralia. And if you're thinking that this small crew is a group researching the decades-old mine fire, then you are partly right. They are researchers, and their study is somewhat based on one of the byproducts of the fire. The surprise for you is that they are looking for spiders. Why? Well, it's part of a larger project that's trying to establish how mercury moves through the food chain.
A number of recent studies, starting about 2008, found that spiders are really good at concentrating mercury, and mercury is showing up in places that we normally wouldn't associate with higher mercury loads. So for example, most people hear about fish and mercury and that you shouldn't eat more than X number of fish, and the EPA has guidelines about that. And in 2008, a researcher, Dan Crystal, found that songbirds that don't feed on fish actually had higher levels of mercury than birds that do eat fish, which kind of threw off the whole paradigm of how mercury travels. And so he investigated why that might be and what the birds were eating, what the songbirds were eating. And about 70% of their mercury was coming from spiders, even though only about 30% of their diet. So spiders have a lot of mercury, and the ones that have the most tend to be ground-dwelling spiders, the ones like we're collecting here, especially wolf spiders, which is what I've been studying for the last 25 years. So then the question is, why do wolf spiders have so much mercury, and what's eating them, and how is it moving from an aquatic system to a terrestrial system? And the original idea is that mercury comes out of power plants, primarily as a source, burning coal, and it gets into aquatic systems. It becomes methylated mercury, which is the part that's biologically active. It's the poison that accumulates inside of animals, and then as other animals up the food chain feed on it, it becomes more and more concentrated until it reaches toxic levels. And so most of the research has been done on aquatic systems because it takes bacteria in an aqueous environment, an aquatic environment, to methylate it. But we're finding spiders that have methylated mercury in them at very high levels, like the same level as halibut, which is a fish that has pretty high levels of mercury. And we're finding high mercury levels here in these spiders. And what's interesting about that is it's not associated with an aquatic ecosystem. This is primarily, almost entirely a terrestrial ecosystem. And so it's possible for that methylmercury to end up in the terrestrial environment without the water source. And that runs counter to a lot of what we thought we knew about mercury and how it moves through food chains.
Persons and his students also have been looking at spiders at power plants and along the river, and have found mercury levels 3 times as high as they would find in a soybean or a cornfield. The problem with power plants along rivers is that they couldn't separate out the mercury from the river. What they found in Centralia is essentially a coal-burning power plant without a nearby river, and the result was mercury loads in spiders that were 9 times higher than normal. The mercury spider study has been going on for 2 years, and they've collected 1,800 spiders at 26 sites. Persons told us they're finding that bigger spiders are eating smaller ones, and their best guess now is the mercury gets more concentrated each time they cannibalize. This day wasn't exactly ideal for collecting spiders, but we joined in the hunt, and moments after talking with us, Person scooped up his first of many. And that's pretty much how it went for a time, us talking to Persons, and then an interruption to scoop up a spider. There was even a brief break for an anatomy lesson to tell male spiders apart from females, which of course led to an outbreak of juvenile humor that you would only encounter among boys.
See the little black things in the front? Those are pedipalps, so those are copulatory organs. So if you see enlarged pedipalps, the 2 little appendages in the front of a spider, if they're bulb-shaped, it's a male, and if they're not, it's a female.
And you can tell that just by looking at it.
Yeah.
Oh,
you can now. You know how to sex a spider. Yeah. So this is a male, and in this case, it's black. And in these species, they actually wave them as part of their courtship display. Mm-hmm. So they wave their genitals around. Yeah. which isn't uncommon for some wolf spiders, but
I'm sorry, I couldn't resist. I just stopped recording because I was laughing.
Persons conceded pretty quickly that his students are better at catching spiders than he is. I was able to locate a spider by flipping over a rock, and it still had an egg sac with it, so points for me. But I didn't rest on my laurels and continued looking in what became an addictive pursuit. One of his students ended up catching a spider that still had its babies on its back.
Found one with babies on its back here. Oh no, I think it's just an egg sac that's about to hatch. Oh no, I think those are babies. No, those are babies. Probably. See its little, how its back looks really weird. All the babies, after the egg sac hatches, just pal on the mother's back, and she carries them for a little bit.
Are there babies on that mother?
Yeah, you can see how weird her abdomen looks here. And those are all babies. I don't particularly like bugs or insects of any kind, but like this doesn't really bother me as much as I thought it would. It's better than being at my house.
Persons also told us that they may have discovered a new species of spider at this spot, and they planned on taking it to a meeting of the International Arachnological Congress over the summer in Colorado. It turns out it was a new species, but they haven't written a paper on it yet. They did manage to find both males and females, bred them, and are now rearing spiderlings in the lab. The other thing that has come out of the mercury study is another study, which often happens.
One of the protocols for looking at total mercury in a spider is you have to rinse them. So you have to dunk them in water and get all the dirt off or whatever. And so we thought, you know, maybe we can fold this into an experiment. So we were interested in sort of which spiders are able to persist underwater for different periods of time, especially, you know, spiders that are by the river and the water comes up in a couple hours. What happens? Do they run away? Do they drown? Do they hold their breath? And so we're looking at that, and we've done that to about 1,700 spiders or so, where we dunk them underwater for 3.5 hours, and then we pull them out and we see how many of them were active the whole time underwater versus how many were able to recover. They looked like they were dead, and then 8 hours later, we look at them to see if they're back to normal. And we're seeing some pretty big differences.
Is it differences among types of spiders or sizes of spiders?
Yeah, different species, different families. So for example, like wolf spiders, a lot of them can go 3.5 hours, and they're active underwater the whole time. They never slow down, and they never go into a hypoxic coma, as we call it. But other ones, within 2 minutes, they seem to be dead. So they can't tolerate it. So we're looking at if there's particular ecological conditions that or commonalities between species that are able to survive. And some of them have gone 16 hours underwater, and they're active the whole time. So there's real differences between them.
The studies are a collaboration with a researcher at King's College, and it's part of an R.K. Mellon Freshwater Research Initiative grant at Susquehanna for river-based monitoring studies.
Overall, this has a lot of implications for looking at the different food chains, or the food web, if you will, of the area, because the flooding events, we originally thought that they might wipe out spiders, and we think that the spiders might stay. So then, like, their gene pool would persist and their behaviors would persist instead of them being wiped out constantly. And the mercury level, that's something really interesting, because I always thought that mercury was higher in aquatic food chains, but I think they failed to factor in the point that spiders are really cannibalistic, so their biomagnification of mercury is really high. So they have a lot higher levels than you would normally expect in terrestrial food chains.
Now here's a reassuring thing to know, especially if you're not a fan of spiders. So of course I'm being sarcastic right now. If you ever find yourself walking through a field like this, Persons tells us that the number of spiders is a lot higher than you might think. They've done estimates in soybean or corn fields that found around 250,000 of one species per acre. He told us that on a good day, they may collect about 300 spiders, although this wasn't a good day. They also plan to stop along Shamokin Creek to get more spiders from an aquatic environment. Once the spider hunt ends, it's back to the lab, where we caught up with Persons and his students a week later. They were busy weighing the spiders that they caught, along with confirming their sex, and also doing a courtship and mating test. Eventually, we moved on to one of their main studies, dunking the spiders. One was put inside a container with mesh on the one end, and then I had to drop it inside the tank full of water. Persons has been at Susquehanna for 17 years and first became interested in spiders while at Albion College as an undergrad. Up until that time, he wasn't such a big fan. He went on to get his PhD and says part of the reason he thinks spiders are interesting is that there's relatively few people that study them. There's over 46,000 described species of spiders, while there are maybe 10,000 species of birds. While there are more ornithologists in the world than there are bird species, there are maybe 500-ish studying all those spider species. It certainly doesn't help that spiders have terrible PR, with Persons telling us that he always has people coming up to him and telling of a spider that bit them. He says that, generally speaking, spiders don't bite. Persons has handled tens of thousands of spiders and has only been bitten once, and that involved a fair amount of provoking.
It was instructional for me because then I can answer the question,
right.
What's a spider bite like? Which now I know, at least a wolf spider bite.
Did it hurt? I can't remember.
It did, yes. It was extremely painful. It was like a double bumblebee sting, like right on the end of the finger, yeah.
Wow.
The physical trauma of it was impressive.
And did the pain hang around?
It didn't because the venom, and I let her fully envenomate me, which most of the time if a spider bit you, you'd smack it off before you would let it to pump venom in. And a lot of times they don't want to because it's too expensive for them. They want to save their venom, and so you're just not worth it to the spider to envenomate. But I let her do that, and it was like a Novocaine shot. So the pain went away as soon as she let go, and my finger swelled up. But most of my hand went numb at the time, and within an hour it disappeared, and even the tip where she bit me didn't have any pain. So it was a brief but intense.
While at the lab, I did allow Persons to put one of the smaller spiders on my arm, and it was a very interesting sensation to have it crawl all over my exposed skin. The other thing I noticed is that I could feel silk on my arm as the spider moved around, and Persons says that half of all spiders don't even build webs with their silk, but produce these dragline threads as they walk around. It turns out silk is an information media for spiders. For example, a male can tell if a female has mated or not, or in a predator-prey scenario, it can tell if a predator has eaten recently and if it was one of that species. Persons also found himself doing national interviews because of a study he did on the female spider's role in courtship.
So we started looking at what females are doing in those interactions and looking at sex pheromones not as this passive thing that females are constantly producing, but as something they're selectively sending to males as a signal. In other words, we think of it as a chemical courtship signal. Just like males are actively courting females, females are actively courting select males. They'll see a male they like, they produce more silk, more sex pheromone. Males they don't like, they don't. So what our studies found is that females change how much silk they're producing based on what the male's doing. So if they see a male that isn't courting, they put down a whole bunch of silk with more sex pheromone in it. And if they see a male that's already courting hard, they'll put down hardly any.
Persons says when it comes to research, he always tends to come back to projects that are related to either communication or courtship and mating. He thinks sexual cannibalism in spiders, where females eat the male, is a pretty interesting phenomenon. The idea of the problem that a male has when he has to mate with a potential predator, how do you resolve that? And that's an intriguing question of behavioral ecologists.